Welcome to another one of my videos. We're talking about naming with ionic compounds as part of section 9.1 and 9.2. So let's go ahead and get started. Your objective for this video is to determine the charges of monatomic ions and then write names and formulas for binary ionic compounds. Before we get into naming them, let's go ahead and take a minute to define an ionic compound. So pause the video, go back through your notes of chapter 7 and look at what an ionic compound is defined as and what makes it up, and answer that in your notes. So after you've done that, let's go ahead and talk about determining charges for monatomic ions. What exactly are monatomic ions? They're single atoms with positive or negative charge. So we're talking about your cations and anions that we've been discussing before, and how they gain or lose electrons, specifically valence electrons, to gain stability or reach stability. Metals, like you know, tend to lose valence electrons, so magnesium is going to lose its 2 valence electrons to gain a positive 2 charge. You also know that nonmetals tend to gain valence electrons to form anions. So oxygen, with its 6 valence electrons, is going to gain 2 more, and it's going to become a negative charge, O2 minus to be exact, to form an anion. And they do this to reach noble gas configuration and stability. So we can usually determine the charge based off the group number for an element. Magnesium is an alkali earth metal in group 2, and magnesium has a positive 2 charge. Sodium is in group 1, the alkali metals, and has a, let's just get rid of that, +1 charge. And same thing with your halogens. Halogens all will have a -1 charge because it needs 1 electron to gain valence electrons of 8. So you can use the group numbers to determine the charge of an element. But wait, there are metals that have more than 1 charge, and you can't use a group number to determine that charge. And those are your transition metals. Iron has 2 possibilities, Fe2+, where it lost 2 electrons, and Fe3+, where it lost 3 electrons. Copper has 2 possibilities as well, copper +1 and copper +2. So they are metals that have more than 1 charge, and we call them variable charge ions, and we're going to talk about them in another video. But before we do that, how do we write basic chemical formulas that don't have to deal with these different charged atoms? Formula units are used to represent the ratio of cations to anions in ionic compounds. We already talked about this with chapter 7. But there's this new method called swap and drop, so that we don't have to draw out Lewis structures anymore, and we can just use this method and the charges that we determine with monatomic ions. So the swap and drop method, you have 2 examples here. Barium has a +2 charge, chlorine has a -1 charge. We swap the numbers only, okay, not the charges, numbers only. And we put the 1 with the barium and the 2 with the chlorine, and we get BaCl2. Over here we have lead. Lead is another one, it has 2 charges, 2 possible charges, and we'll get into that later. But lead has a +4 charge, oxygen has a -2 charge. We swap the numbers. The 2 from oxygen goes to lead, the 4 from lead goes to oxygen, and we can simplify that down. This is a ratio of 2 to 4, and we can simplify that to 1 to 2. So we can simplify, and we should simplify our chemical formulas when you're writing them. When naming and writing formulas for ionic compound, the metal cation comes first, followed by the non-metal anion. So metal cation comes first, then the anion. When we are naming them, the nonmetal's ending is changed to IDE. We do this so that we can know the difference between something like sodium element and the sulfur element and sodium sulfide, which is a compound of Na2S. Okay, so we change the name to show that it's in a compound and kind of bonded together ionically. Chlorine becomes chlorine, chloride, sulfur becomes sulfide. I'm sorry that I kind of wrote over that. So try these. Try to come up with the chemical formula for the following: sodium chloride, magnesium chloride, potassium chloride. Pause the video, try them, bring them back to class tomorrow, and we'll go over it if you have any questions. And then also try to name the following: NaI, MgO, and CaS. Try those problems out, bring it tomorrow, and we'll discuss it. Other than that, have a great night, and see you later.